Hello and welcome. When a rigid body component is attached to a game object, it subjects the game object to the control of Unity's physics engine. The recommended way to move a rigid body is to apply forces on it to move it and let the physics engine do the calculation for the motion instead of changing the transform position or rotation. In this tutorial, we'll be looking at how to move rigid bodies and then how rigid bodies behave with respect to velocity change, applied forces, and collisions. A game object with a rigid body component attached immediately responds to gravitational pull. The capsule in this scene has no rigid body component attached and so does not fall due to gravity. But it falls freely due to gravity when a rigid body component is attached. However, it does not respond to gravitational pull when the its kinematic property is set to true. A kinematic rigid body is a rigid body with its kinematic property set to true. A kinematic rigid body stops responding to forces and collisions. The script, called collision test, is attached to both the capsule and the table to detect collision and display messages in the console window when a collision is detected. At the moment, the table is not a kinematic rigid body and so will not respond to collisions from the capsule. Now let's set the its kinematic property of the table's rigid body component to true. You will notice that the script attached reports of collisions, but the game object does not move. It simply does not respond to the collision or force applied. In a script, the fixed update function is recommended as the place to apply forces and change rigid body settings. A non-kinematic rigid body can be moved by changing its velocity. In our script, the velocity of the game object is set to vector 3.right. Since velocity is measured in units per second, it means the object will move at 1 unit per second. The mass of an object does not impact the velocity of that object, but the drag property does. The mass of the moving capsule increased, but it kept moving at its constant velocity. But when the drag value is increased, it halts the capsule. Remember, you cannot change the velocity of a rigid body when its kinematic is set to true. We can use the input.getAxis to capture keyboard input and change the velocity accordingly. Let's multiply the velocity by a speed constant of 5. You will notice that the object does not fall freely due to gravity as expected. Changing the velocity of a rigid body interferes with gravitational pull. We can somehow work around this by applying velocity only when an arrow key is pressed. Input from the keyboard to trigger a jump is captured using the input.getButton function. The add force function of a rigid body component is used to add force to a rigid body. In the script here, a force is applied to the game object in an upward direction. The force mode is set to force. With this option, a force is applied continuously to the rigid body along the direction specified in the vector. A force mode of impulse applies an instantaneous force to the rigid body. Both modes are mass dependent, thus the greater the mass, the more such force must be applied to move the rigid body. Acceleration and velocity change force modes are mass independent. We can nullify the effect of gravity on the capsule by accelerating the game object by the same gravitational acceleration, but in the opposite direction. You can find where the acceleration due to gravity is set by going to Project Settings, then Physics. While the velocity of a kinematic rigid body cannot be changed, you can use the move position function of the rigid body component to move a rigid body, whether kinematic or not. Please subscribe to this channel for more videos. Thank you.